Okay, on to units of measurement. So you might have heard the term SI units before. Those are the International System of Units, the ones that we use all over the world. They are an agreed upon set of base units. You will use these. Okay, now I have all 7 of the base units listed here. However, really, we're going to use the first 5. Electric current and luminous intensity are really more physics related measurements, but we definitely will be doing length, mass, time, temperature, and amount of substance. Those are all relevant in chemistry. So you are going to need to know the units and their symbols. So you've got the meter is M, kilogram is kg. We also measure things on a smaller scale, so you will see grams, that is just a G. Seconds is S, Kelvin is K, capital K, and a mole is MOL. I know it's only 1 letter shorter, but we still do use that as the symbol for a mole. Can't use M because M is already taken by meter. Okay. Now I also have some pseudo SI units, which are really derived units, and I'll talk about what a derived unit is here in a minute. But we often will use a liter as our base unit for volume, or liquid volume most of the time, and a metric ton, not a ton in English, is 10 to the 3rd kilograms, okay? That's one you will need to know. And then the atomic mass unit, or AMU, we will use a lot as well. You can convert into kilograms, and we will be using atomic mass unit often as well. Okay, so now onto the metric system. You're probably familiar with the metric system already. Metric system is based on units of 10. They cause really easy conversions between different numbers, small and large. These are the abbreviations, the most common abbreviations. And what I've circled in purple, you should also circle. Those are the ones that we will use most of the time. Okay, so kilo is 10 to the 3rd of the base unit, which would be grams in our case. Centi is 10 to the -2nd grams, milli 10 to the -3rd, micro 10 to the -6th, and nano 10 to the -9th. Okay, so we use a lot of small scale things, so you will see these, and then kilo is our large scale that we usually use. Nothing bigger than kilo generally. You might see a mega every once in a while, but that's going to be it. Okay, and if you need help with metric conversions, you might want to check out my website. I do expect you to be able to use these numbers and reference them. I do not expect you to memorize all of these. Okay, this class is not based on memorization. It is based on application. All right, so okay, now for measurements we are going to be making in class, in lab, really. An important thing to point out is the difference between mass and weight. When I tell you to measure something in the lab, I'm going to tell you to mass it, not to weigh it, because we care actually about mass. Now, what's the difference? Mass is the amount of matter, usually in grams or kilograms, that something has. So how much stuff is in it? Now, notice on this example, my mass on the moon and my mass on the Earth are exactly the same, 120 kilograms, because the amount of stuff in my body has not changed. Okay, so the mass does not change based on gravity, whereas weight does. Weight is actually a measurement of the pull that the Earth has on you or the moon has on you. So notice the weight actually changes, and this one is measured in newtons, but pounds or newtons, that actually changes whether we're on the Earth or on the moon. Now, yes, I know we are not going to be on the moon. We are not going to be changing our force due to gravity, but mass is always going to be more applicable because it does not change, okay? So when you're in the lab, when I ask you to do things, what I want you to do is mass it. You're gonna use a balance to take the mass. Okay, so let's move on. Temperature conversion. So we're gonna measure masses. You definitely are gonna have to measure temperatures in the lab. So there are 3 different temperature scales. They're based on different things: Kelvin, Celsius, and Fahrenheit. You do need to be able to convert between all 3 of these. So I have not necessarily the definition, but what they are based on. So you may not know, Kelvin, which was the base unit that I mentioned earlier, is actually based on the kinetic energy of molecules. Okay, if they have 0 kinetic energy, meaning they're not moving, that is considered absolute 0. Okay, so molecules at 0 would be not moving. Now we haven't gotten there, maybe someday we'll get close, but not moving is absolute 0 Kelvin. The more movement there is, the higher the temperature. Okay, so Kelvin is based on kinetic energy of molecules. Celsius is based on water's melting and boiling point. So water melts or freezes at 0 degrees Celsius, and it boils at 100 degrees Celsius. So at 100 degrees Celsius, so it's actually based on water. So what is water doing? Fahrenheit, on the other hand, you may not know, is actually based on how we feel, how a person feels. Okay, so like if it's 100 degrees outside, that's like 100% hot. But that's really why we use Fahrenheit, because it's more relevant for us and how we feel as humans. So you do have to be able to convert between all of these. This picture is going to be really helpful. But these are the equations to convert. These are things that I would give you. Again, this class is based on application, not memorization. So Kelvin is degrees Celsius plus 273.15. And Celsius is equal to Fahrenheit minus 32 times 5/9. So you do need to practice applying these. These answers are going to be on any work that I give you, or sorry, these equations are going to be on any work that I give you, but you do have to be able to use them. Okay, example number 3, a student with a fever has a temperature of 103.5 degrees Fahrenheit. Express this temperature in degrees Celsius and Kelvin. Now watch your order of operations when you're converting from Fahrenheit to Celsius. If you need help with the algebra, please let me know. Now, hopefully what you did is you actually tried to convert these using your calculator or writing out the work. If you just looked it up online, that's not going to help you in the future. You are not going to have your computer with you when you're taking the test. So make sure you can actually do these calculations. You should have gotten that Celsius is 39.72 degrees Celsius and Kelvin is 312.9. Okay. All right, moving on. I mentioned derived units earlier. These are really any units that are composed of 2 or more SI units put together. So 2 different measurements combined. So density, for example, is a derived unit. It is mass divided by volume. You can measure the mass of something, you can measure the volume of something. The density is the ratio of those 2. Velocity is also a derived unit. It is distance over time. So really any units that are not those base units or those base SI units are going to be derived units, something created from multiple measurements.